a term used to describe the acidic or alkaline effect of a food after it has been metabolized is potential renal acid load. It is broadly recognized that when this value is positive, it indicates that the food is acid forming. Some examples include certain animal proteins, as they produce more sulfuric and phosphoric acids, which contribute to a higher acidic ash, certain dairy, and certain grains. Conversely, a negative value suggests that the food is alkaline forming, such as most plant sources. To put it simply, after metabolism, the conversion of food into energy, the metabolized food can be characterized as acidic, neutral, or alkaline. The body must manage these characteristics to maintain its natural balance and avoid any negative disruptions. According to Lee, 2024, metabolism involves a series of chemical processes that convert energy from food into usable forms for cells and organisms. This process generates waste byproducts which can be referred to as metabolic ash or acid ash, relating to the acidic nature of certain foods. An acid is defined as a substance that donates protons or H+ ions in a solution, resulting in a pH of less than 7. Acids can act as irritants, especially when consumed in excess. The impact of acidity from various foods is often subtle and can be overlooked, especially in popular diets where certain foods are pushed and consumed heavily for personal goals. On the other hand, a base is a substance that can neutralize acids and is often referred to as alkaline. Acidic byproducts, particularly those derived from animal sources, require the body to neutralize them. While healthy individuals can typically buffer these fluctuations, excessive loads constrain normal functioning. This raises an important question. To what extent does this matter in maintaining a diet that supports optimal physiological function and development? Another important factor to understand is net endogenous acid production, NEAP, which estimates the absolute rate of metabolic acid production from a total daily diet. The post-metabolic pH is influenced primarily by 5 nutrients. 1. Acid-forming components, protein, especially certain sulfur-containing amino acids, phosphorus, and chloride. 2. Alkaline-forming components, potassium, magnesium, calcium, and sodium. However, the mechanisms affecting pH balance are quite complex. The pH of food is different before consumption. When food interacts with saliva and digestive enzymes, its pH changes. This alteration continues as the food engages with various digestive and metabolic pathways, leading to a final metabolized pH that can significantly impact the body, determining whether it is acidic, neutral, or alkaline. The pre-existing pH environment in the body also serves as a crucial foundation before food is metabolized. If the body is in an acidic state, consuming additional food can either neutralize or worsen that condition. Over time, this can affect multiple physiological systems since maintaining chemical homeostasis is essential for overall health and well-being. When it comes to proteins, it's important to note that while certain proteins are generally neutral molecules with neither acidic nor basic properties, their metabolism often results in the generation of acidic byproducts. These byproducts can contribute to an overall acidic environment in the body, particularly those from sulfur-containing amino acids. Although proteins can act as buffers that help maintain pH balance, their metabolism often leads to a net increase in acidity. Factors such as overall diet and metabolic state can influence how pronounced these effects are. Certain amino acids, like aspartic acid and glutamic acid, are inherently acidic, while cysteine and homocysteine contribute to an acidic environment through their metabolic processes. In general, the acidic byproducts produced during protein metabolism tend to have a more significant and lasting impact on the body's acid-base balance than their temporary buffering capacity, especially with high protein intake or during prolonged periods of metabolic stress. Thus, strategically using natural base-forming sources becomes vital in routines centered around body development, where protein quantity is a key component. Additionally, in the context of acid load, grains typically refers to refined grains, which are higher in potential acid-forming compounds compared to their fiber-rich whole grain counterparts. Another example, Lemons in their original form are acidic due to citric acid, leading to the misconception that they increase body acidity. However, upon digestion, they produce alkaline byproducts, which enhance the body's overall alkalinity despite their initial acidity. Ultimately, the key lies in maintaining balance among these factors rather than leaning toward one extreme. Although the body works to ensure an optimal pH balance, excessive acid load over time may strain these systems and, if left unchecked, may create negative outcomes such as non-communicable diseases. High dietary acid load, DAL, can raise uric acid levels, which may increase the burden on renal function. Although dietary acid load is influenced by several factors, recognizing the nature of certain diets and food sources can help create a more sustainable, body-friendly approach. In holistic sciences, food serves as both fuel and medicine. Maintaining a balanced acid-based diet is fundamental for long-term well-being, as it may prevent chronic metabolic issues, support optimal physiological function, and preserve homeostasis in bodily systems based on individual suitability and health status. Thanks for listening in, subscribe to the channel, and stay connected for more holistics.